Welcome to all. Myself, K. Srisha, working as Assistant Professor in Mechanical Engineering Department in Amir Engineering College or Amir College of Engineering and Technology. I would like to teach the subject of thermodynamics to second year, first semester. Now I start the introduction of thermodynamics and included with definition of thermodynamics. So what is the definition of thermodynamics? Thermodynamics is a science that deals with heat and work and those properties of substances that bear a relation to heat and work. So, thermodynamics is a science that deals with only heat and work and those properties of substances that bear a relation to heat and work. So, that is a definition. So, thermodynamics. So, thermo means temperature and dynamics is motion. So, heat is in motion. That is nothing but thermodynamics. So, how the heat is in motion? Actually, we are in motion is nothing but we are moving from any place, from this place to our college to house to college. So we are moving with the help of our legs. But how the heat is moving? In definition only, it is saying that thermodynamics. Then how the heat is moving? That it is using the law, one of the law. That law is nothing but law of conduction. What the law of conduction says, heat moves from one place to another place. That is in the motion with the help of a law of conduction by using the law of conservation of energy. What the law of conservation of energy says, that energy neither be created nor destroyed, but it can move from one place to another, but it can transfer one form of energy to another form of energy. That is known as law of conservation using thermodynamics with the law with help the law of conduction. So here is the thermodynamics. What is thermodynamics? The science of energy that concerned with the ways in which energy is stored within a body. Energy is in a system is there. Energy is stored within their body. Energy transformations mostly involved heat and work movements. Okay. So fundamental lies the conservation of energy principle. Already I told. Okay, energy cannot be created, not destroyed, cannot be created or destroyed, but it can only be transferred from one form to another form. Here, I can show how the energy can transform one form to another form. Actually, pump is nothing but water is pumped to the boiler. Here, boiler, what is that? Water is heated. The boiler changes the phase. Water is converted into vapor, and this vapor is moved on to the turbine. This turbine converted to turbine will be rotate the shaft. So the shaft is rotating here. Okay, here the steam is water is converted into steam is nothing but heat energy. These heat energy is applied to the turbine, and when we apply to the steam energy, nothing but heat energy. So this heat energy is converted into mechanical energy. So when this shaft is coupled, connected to the electric generator, and this electric generator converted the mechanical energy into electrical energy. So heat energy is converted into mechanical energy, and mechanical energy is converted into electrical energy. So the law says that the fundamental law is the conservation of energy principle. Energy cannot be created or destroyed, but it can only be transferred one form of energy to another form. So in thermodynamics, the most important terms are system, boundary, surroundings. So what is system, boundary, surroundings? So system is nothing but so system is nothing but the thermodynamics is defined as definite space or area on which a study of energy transfer and energy conversions is made. So in a thermodynamic system, it defines a particular definite space or area on which they study. For example, the book is nothing but a system. In this particular system, we study. That is a system. So outside of the system, it considered as surroundings. Outside the system is considered as the surroundings, and in between, which separates a system and surrounding, which separates one layer, that is nothing but boundary. So it separates the system and surrounding is nothing but the boundary. The system and surroundings are separated by the boundary. It may be fixed or mobile or imaginary. Okay, it will not occupy any volume or mass in space. So system, so what is system? So we have definite space is nothing but system. What is the surrounding? Outside the system is nothing but surrounding, and its separate system and surrounding is nothing but the boundary. And next thing is control volume and control surface. Control volume is nothing but a specified large number, the thermal device, as mass flow in, a mass flow out of a system called as control volume. For example, one system is there, in this system mass flow in and mass flow out is nothing but a control volume. A control surface, both mass and energy. For example, mass flow in, flow out, and included with the energy also, like heat energy, like for example heat energy. So heat in and heat out, so both mass and energy can cross the boundary of a control volume, which is called a control surface. Okay, so control volume, control surface. What is universe? Already we discussed system, surroundings. So system plus surroundings together comprise a universe. So comprise a system and surrounding is called universe. Next, temperature. So what is temperature? Already most of the people know the definition of temperature. It is defined as the measure of velocity of fluid particles. It is a property which is used to determine the, actually it is used to determine the hotness or coldness. The level of heat density of a body is nothing but temperature. What is temperature? It is the degree of hotness and degree. To determine the degree of hotness and degree, all the level of heat density of a body is nothing but temperature. And next, the temperature in degrees centigrade. So 100 degrees centigrade is the boiling point of water at atmospheric pressure. So in terms of Kelvin, so 100 plus 273 is nothing but 273 373.15 Kelvin, and 212 degrees centigrade Fahrenheit is 212 Fahrenheit is nothing but in terms of Fahrenheit. So what is the boiling point of water at atmospheric pressure in terms of degrees centigrade is 100. In terms of Kelvin, 373.15. In terms of Fahrenheit, 212. So very important in the problems point of view. So careful to study these points. And freezing point. Freezing point of water is nothing. Freezing point of water is at 0 degree centigrade. In terms of Kelvin, 273.15 Kelvin, and Fahrenheit, 32 degrees Fahrenheit. So those are all the terms how to, in case of, if you know the value of TC and then we convert, then you will be converted into Fahrenheit. If you know the Fahrenheit, you will be converted into degree centigrade. If you know the value of Kelvin, you will be converted into in the form of degree centigrade. So those are all the formulas. What the value we have, then you will be converted into another form. Okay, so those are all related to the temperature. What is temperature? It is determined to degree of hotness and coldness of the level of heat and density of your body. Temperature. So freezing, boiling point of water is 100 degrees centigrade. Freezing point of water is 0 degree centigrade. Very important. And next, classification of thermodynamic system. So in classification of thermodynamic systems, we have open system, closed system, isolated system. So let us we start with open system. So what is open system? One in which both energy and mass cross the boundary of the system is nothing but open system. So if you take one pipe, so one pipe, two sides are open. So one side is mass is entering and another side is mass amount of water is going. So mass in and mass out, that is nothing but mass in and mass out is nothing but open system. Closed system. What is closed system? On in which mass does not cross the boundaries of the system through energy may do so. Closed system is nothing but in a cup of hot coffee. Okay, we have one cup of hot coffee. So hot is nothing but heat. Heat is nothing but energy. Here the mass is constant. Mass is not changing. Okay, it cannot cross the boundaries, but heat is decreases. That is nothing but energy crosses the boundary. So here closed system, what it says, mass does not cross boundaries. Only energy may cross the boundary. That is closed system. So next we go to the isolated system, one in which neither mass nor energy crosses the boundary of the system. Is that if what it means, energy nor energy, neither mass nor energy. So not it doesn't not mass is not flowing included with the energy is not crosses the boundary. So mass and energy not doesn't crosses the boundary of the system is isolated system. The best example is our thermo flask. In our thermo flask we have poured some hot coffee and closed the lid. So neither energy nor mass crosses the boundary of the system is known as an isolated system. So here are the examples. Here we have a piston and cylinder. This is the closed system. Here mass is constant. Mass is constant. Mass is constant. Here mass in and here is a closed system. Okay, here is a closed system. Mass is constant, energy only crosses the boundary. So closed system only energy crosses selected boundary. So energy in, energy out, but mass no in and out. So tightly capped cup of coffee, that is the closed system. Here open system is the mass in and mass out, and energy in and energy out. Both mass and energy can cross the selected boundary. So both mass and energy cross the boundary of the system is known as open system. Here this is the control surface. Here it is the control surface. Inside the volume is known as control volume. So open cup of coffee, open system. Okay. I'm sorry. This cup of coffee is only used for open system, and closed system is a tight lid is closed with closed. Okay, here this is the best example. Tightly capped cup of coffee is a closed system, and type of system open system is an open cup of coffee. In closed system, only energy cross the system. Only energy cross the system is a closed system. Example, tightly capped cup of coffee, and open system open cup of coffee. So here mass and mass out, energy in, energy out. So both energy and mass cross the boundary of the system is open system. And isolated system, neither mass nor energy cross the doesn't cross the so boundary of the system is isolated system. Makes a best example, coffee in a closed well insulated thermos bottle, that is isolated system. So here open system, here in open system energy and mass crosses the boundary of the system. In closed system only energy cross the boundary of the system. In isolated system neither mass nor energy cross the boundary of the system. Okay, very important. Macroscopic versus microscopic approaches. What is microscopic approach and microscopic approach? Okay, here macroscopic approach. In this approach, a certain quantity of matter is considered without taking into account, okay, the event occurring at molecular level. The analysis of microscopic system does not require knowledge of behavior individual particles. Macroscopic properties are effect of action of many particles or average value of large number of particles. In this approach is followed in classical thermodynamics. So tire pressure measured at a station. So I will give one example regarding the macroscopic approach. So already we discussed taking example a boiler. So in boiler water is heated. So when the water is heated, the phase change, water is converted into steam. In this steam it would be like some gas molecules. So it is having a different random of molecules uh, between them. So by using macroscopic approach, we are going to calculate the values of pressure and temperature. By using macroscopic approach, we are going to calculate the values of pressure and temperature without using of a barometer and thermometer. So by using macroscopic approach, actually we are having a large amount of molecules inside the boiler. Not taking the large amount of molecules at a time. You are taking a small amount of molecules and taken the values at a time, and we calculate the pressure and temperature by using the macroscopic approach. Average behavior of molecules we are considered, and we're taking the values, and finally we can calculate the values of pressure and temperature with the help of macroscopic approach. So the macroscopic approach, it is also called as, and the macroscopic approach, it is followed in classical thermodynamics. So one way called as the macroscopic approach is followed in the classical thermodynamics also. Okay, so my next one is microscopic approach. So the given example, tire pressure measured station, macroscope, by using macroscopic approach. What is microscopic approach? Microscopic point of view, system is made up of very large number of discrete particles known as molecules and atoms. So microscopic approach require knowledge of behavior individual particles. Microscopic properties or effect of action of individual particle. This approach is followed in statistical thermodynamics. So microscopic approach, it followed in statistical thermodynamics. What is it? What does it means that in macroscopic approach we are taking average behavior of molecules, but it is easy to calculate. It is easy to calculate the behavior of molecules and calculate the values of pressures and also temperature. In macroscopic approach, it is taking so much of time. Because of it here, we are not considering the average behavior of molecules. We are considering the individual each part of each molecule of each molecule of particles, each we are considering each molecule. It is taking so much of time. So one is P1, another is P2, and this. So it is taking so much of time by taking an individual molecule. So the macroscopic approaches we are not follow very much comparing to the macroscopic approach. So it is also it is also used to calculate the pressure and the temperature. Okay, so example properties of atoms. And next, microscopic world, individual molecules having position, velocity, mass. In macroscopic world, pressure, volume, temperature, and number of moles. Okay, the next, concept of quantum. Concept of quantum is nothing but matter is made up of atoms. Matter is made up of atoms that are widely spaced in the gas phase. It is very convenient to disregard the atomic nature of a substance and view it is a continuous homogeneous matter with no holes. That is a quantum. So when we consider the macroscopic approach, in macroscopic approach, we calculated one group of molecules, and with continuous it is changing the group. So I think what does it mean? It is continuous to measuring. It is continuous. We are going to continuous to measure. So it does not take any delay. It takes the values continuously, and no holes is nothing but no gaps in between them. So the water molecules there will consider one set of molecules. At the very first we can calculate the another. At the very first we can calculate the another. So the step by step there is we cannot delay with the one to one group of molecules. That is nothing but a continuous. But take from microscopic approach, the concept we can take the concept of a quantum. So quantum is nothing but there is no holes. It is continuous. View it is as a continuous homogeneous matter with no holes. That is a quantum. Okay. And next, thermodynamic properties. It is very important in the point of thermodynamics. So what are thermodynamic properties? In thermodynamic system we have properties. In thermodynamic properties we have two types: intensive property and extensive property. What is intensive property and what is extensive property? Intensive property, so independent of mass of the system, is intensive property. Extensive property depends upon the mass of the system, is extensive property. What does it mean? Intensive property, independent of the mass. Independent of the mass, pressure, temperature, density, concentration, melting point, boiling point, surface tension, viscosity, etc. It is independent of the mass of the system. Okay, so I will give one example for intensive property. I have 1,000 liters of water. So 1,000 liters of water at the temperature is 100 degrees centigrade. I will change. I will 500 liters of water into another glass, same size and same shape, which it is same as a like a first one. So same size. But the mass is taken into two halves, 500 liters and 500 liters. Then after we can calculate the temperature with the help of thermometer. The temperature is same as 100 degrees centigrade. Here you can observe one thing: mass is independent of the system, so temperature is constant. That is nothing but a intensive property. Okay, temperature is constant, it doesn't change. When mass changes, but mass is divided into two parts, but it doesn't change the temperature. Okay, that is nothing but intensive property. Extensive property, in extensive property I also do same thing. So I have the 1,000 liters of water. So firstly the shape is the same, but I will take the another shape and size. So I will change some dimensions like length, width and breadth, length, width and height. So when the mass changes and it shape changes, the system shape sizes also changes. Here when the mass is poured into another different shape, it changes the pressure, temperature, density values. So it depends upon the mass. It depends upon the mass, volume, internal energy, capacity, enthalpy, entropy. We can conclude the extensive properties. So independent of mass of the system is intensive property. Extensive properties depends upon the mass of the system is extensive property. Here the properties. Properties of a system is a measurable characteristic of a system that is in equilibrium. Okay, properties may be intensive or extensive property. Intensive property are independent of mass, temperature, pressure, density. Extensive property varies directly with the mass, volume, energy, enthalpy. I will give a best example. Actually, we can divide mass into we can divide the mass divided. Volume also we can divide, but temperature we cannot divide, pressure we cannot divide, density you cannot divide. Already I told the example. So I have to in intensive properties, mass is divided, but temperature is divided. No, temperature is not divided, pressure is not divided, density is not. So where the terms are divided is known as extensive properties. Where the terms are not divided is nothing but intensive properties. I hope you understand, students. So where the properties are divided is divided or extensive properties. Where the properties are not divided is nothing but the intensive properties. And next, properties of system. So specific properties, the ratio of extensive property of a system to that of mass, so is called an average specific value of the property, also known as intensive property. What is the specific property? So volume by mass. Volume is nothing but extensive property. Extensive property divided by mass is equal to specific volume. Specific volume. So that specific properties is known as intensive properties. I think you understand. Specific properties is known as intensive properties. How the specific properties we get? Specific properties it defines extensive property to mass. It will give intensive properties. Okay. Specific volume. Volume by mass is equal to specific volume. Total energy by mass. Specific energy. Total energy by mass. It gives internal energy. I hope you understand, students. Thank you.